Hello! Thank you for coming to this video today, guys. I really appreciate it. This is the Cardano Aura episode number 6. This is Cardano's Use and Utility podcast, where we bring over the people that are adding value to Cardano. And I've always been interested in this. I've heard Charles talk about RINA all the way back since 2017. So what is RINA, real quick, before we go into this video? So RINA is essentially a new way to do the internet, right? And that's why this is a bit technical. You know, a lot of you guys maybe don't even know. I think the best way to understand really the differences is to know more about the way the internet works today, right? We have TCP, IP, and it's really just, we have addresses, you know, and this is a very basic overview, but you have an address to an address, and that leaves a lot of vulnerabilities for hacking. It's just there's a lot of issues with the current. There's some issues with scalability, and because of the hacking, there's some issues with cost. There's a lot of issues with TCP/IP, and if you follow it all the way back to 2017, when Cardano was really announced by Charles, he said that I got a quote here for you. So he announced his plans to adopt RINA as a future-proof and scalable foundation to support the networking needs of Cardano. So, I mean, that shows some validity to this, you know, because Cardano is really all about scalability. You know, that's one of the key features that we're looking for to beat Ethereum is not only scalability, but also kind of like a scientific approach, right? So, to me, RINA is Cardano in the sense that it's a return to science, right? So let me read another quote from actually a university, and that's where I drive this from, is RINA is a return to the fundamentals of networking architecture based on strong and variant design principles and a rigorous and scientific approach to cause and effect, right? It uses a recursive method instead of the method that's used currently with the internet. And this, as you can see, I did a little bit of research before doing this interview, but not as much as I should have. I will work on that in the future, because this is a really complex topic, and as an interviewer, I should have been more prepared to really kind of dive deeper into the important parts. But I hope you guys enjoy this interview. It is pretty complex. I had a great time, and thank you, Gary, for coming on. Also, if you guys want to support the channel, the vote was actually delayed for the proposals, and that vote was actually delayed another month. So just stay tuned for information on how to vote yes for this podcast if you enjoy it. There'll be another one coming next week, as always. Also, delegating to Bloom 3, my staple, also supports this channel and this podcast. I would really appreciate that. And also, I have decided that if we do get voted in for the podcast, I won't do any ads on these podcast videos. I don't know, it feels right, you know, if you're paying me to do the podcast, it'll be completely ad-free, just for you guys to watch. So I'm looking forward to that, you know. So I hope you guys enjoy this podcast, and thanks again, Gary, for coming on. So I'm going to add the intro in myself, so I just click start, but thanks for coming on. I really appreciate it, Gary. I'm excited to learn more about RINA and really more about yourself. So how are you doing today?
Oh, well, it's 5 o'clock in the morning in Okinawa, Japan.
Just getting started.
Yeah, bushy-tailed. Okinawa is traditionally like a very touristy place, but with all the travel restrictions nowadays, it's kind of our own little island. So it's our own little secret.
So yeah, it's a lot different now, isn't it, with all the restrictions? So like, yep. Kind of like streets are empty. Yeah, I actually moved to a big city during the pandemic for school, and then obviously the school got canceled. So all the local people, like, they look at my experience moving here just as a crazy experience, because they've lived here their whole lives and kind of seen the city popping, you know, and then I move here and it's empty, and this is the only way I've ever seen it, you know, so that must be interesting.
And Cardano, I guess, started in Osaka, didn't it? Up in the mainland. I know that, with Jeremy and Charles. Right?
Mm-hmm. So I've heard. Yeah, I've always wanted to visit there.
For a quick flight away.
Quick flight and some vaccines.
No, they're not. They're not too strict on that here in Japan.
Really?
Yeah, we wrote their constitution. General Douglas MacArthur. wrote the Japanese Constitution.
And that was right after World War II, wasn't it?
Yes.
Yeah.
Anyway, so to introduce myself, I originally was in the United States Marine Corps. As a lot of us here, we have a community of expats, you would say. A lot of them work with the military that are still here in Japan. And a lot of us, we don't have any affiliation with the military at all. I'm the technical director of GLBB Japan, which is a communication service provider nationwide in Japan. We even have sites in Los Angeles. So we're an NTT partner, we're a SoftBank partner, a KDDI partner. So, in the communications reality, we all sort of use each other to get fiber or path to provide our services to customers, which is direct internet access. We call it DIA, or Ethernet services, or wave services, which is dense wave division multiplexing, and neat stuff like that. And we can pretty much take you on a circuit anywhere throughout Japan. Or sometimes, like, we bring some of our customers are cable TV companies, and we bring their internet, or not their internet, their TV feed from the US into Japan. So it's a pretty diverse customer base that we have, from the individual user at home, and we actually offer direct fiber to their house. So that's 1 gig up, 1 gig down, not on passive optical networking, but on dark fiber, you would say. On our website, we call it F-Express. And we're so I was in the Marines, and then I got out and I focused on network engineering my entire career. I actually sold the first 10 gigabit Ethernet port in the world with our partner in Japan, but I was the only one from my company on the ground involved and engaged to do it. We sold, it was 80 10 gigabit Ethernet ports for $60,000 each to NTT.
What year was that?
2003.
Really? Yeah. See, I'm not even up to a gigabyte yet here, so someday.
So I'm used to being on the cutting edge or the bleeding edge of technology. One good example is we sell services nowadays. A traditional ISP will sell MPLS. So if you look at all the carriers that have been entrenched in this space, they keep trying to break out their MPLS blade to solve problems. Their Swiss Army knife always has the MPLS blade. And we don't use MPLS ourselves. We use VXLAN, which is just another overlay. MPLS is sort of an underlay, and then we use another overlay, VXLAN. And at first, everyone says, well, where's your MPLS? We said, we don't have it. And all these RFPs would come out, and they'd say, but you guys are cheaper. And we say, yes, because it's VXLAN, and the equipment is cheaper, and that's the point. So more commodity, follow the trend, and the price goes down. And it was the data centers, inside the data centers was doing the VXLAN. And the VXLAN is basically solving a lot of the problems with bringing layer 2 over the internet. So you can connect point to point your offices, sort of think of like a VPN. And there's even standards for it. They call it the Metro Ethernet Forum. They have standards that you have to pass for these types of services, which could be basically E-line, they call it, which is point-to-point overlay to offer a virtual Ethernet circuit point-to-point, or it could be point-to-multipoint as well. And these are some of the most popular services in all of computing right now. Is either internetworking is either wave services, where I can get just a physical wavelength from, let's say, here to Los Angeles, Tokyo to Los Angeles. And the other one is the virtualized Ethernet overlay services. And then finally, you have the direct internet access. And yeah, sure, there's a lot more of those customers, but it doesn't make as much money nowadays as using that same network and writing it as an overlay and selling point-to-point
Yeah.
Ethernet services. So I understand the complexities that we face in networking today. We have some of the most premier customers in the world on our network, actually. So we can't go down. And so because of that, the board of directors had assigned me and said, well, Gary, think outside the box. What are we going to do in case of a disaster for business continuity? And it's a big thing because as we would go to our carrier partners, think the big ones, and I don't want to mention them, but they would always come and they'd say, okay, this is all great. We love your proposal. But before we sign the contract, where is your business continuity plan? And it's great, and we like it, and we work on it, but we always think it's kind of vanilla. It really doesn't stick out there because I'm backing up the internet with the internet. It really doesn't make sense. I can tell you about one time we had a problem where our internet core routers were crashing from a certain vendor. And it was coincidentally, my entire team was at a party on a remote island. And I said, no, I'm going to stay back to handle the network in case anything happens. And sure enough, the core router started crashing. And the vendor had told us about this problem maybe 2 months before. And we were just being lazy bones and we didn't upgrade. And as soon as it started happening, I kind of knew it. I said, oh, I got to run to the data center and start these upgrades immediately. So the internet has a lot of problems with security and manageability. So it doesn't make sense if I were to back up that network with the same network that would crash by a certain crafted packet, which was causing the crashes. So thinking outside the box, we started looking at RINA, and we feel, it's stuck in academia, which is perfect for us. We love, like I said, our first 10 gigabit Ethernet port in the world. At that time, we were using MSA, Manufacturer Support Agreement optics. They were like this big squares, not the little small form factor pluggable optics we use today, but I mean, these were huge optics.
Yeah, I couldn't imagine seeing something that large to get internet.
Yes. Yeah, it was so like the floppy disk of the day. Well, at that time, my customers here in Japan, they were experiencing bottlenecks with gigabit. The customers had outgrown gigabit, and the only choice was to get higher speed, so they went to 10 gigabit Ethernet. Interesting enough, what you'll find is, well, I don't want to go too far into optical networking before talking about RINA, but well, let's talk about the challenges with RINA first and how that's going to meld with traditional telecom or traditional telco. So what we have is currently today, we have two networks. We have one network where we're selling it, another network that manages that network. We call that one the OOB, the out of band network, which is really nothing more than a BCN, business continuity network. So if there's, we don't manage the devices in line. We don't allow anyone to manage the devices in line because that's where the hackers are, right? So the security model for a carrier today is to do that. You'll even note that Level 3, for example, they bought many companies throughout their history, like GTT, who just got bought for $2.15 billion. But, these companies get this complexity, and the next thing you know, they have 3 networks. And those 3 networks come with 3 out-of-band networks in many cases. And a lot of the vendors, or shall we say the carriers, for their out-of-band network, they simply take their older equipment that is full of security vulnerabilities and never will be supported to fix any bug. And they put that and they say that's going to be the out-of-band network. Because that's what the accountants want. In the service provider space, it's all about RGUs, revenue generating units. And the business continuity network makes no money. The OOB makes no money. It's just sitting there taking up, up 30 to I'd say 10% to 30% of my capacity is spent in and out of the data centers. So we're in like NTT central offices, or SoftBank data centers, or KDDI data centers, or even different independent data centers all throughout Japan, wherever we can get space and wherever we can get fiber. Even like municipalities will get together and they'll form, like they call it a kumai in Japan, where they all get their taxpayer money and say the taxpayers need fiber, and they'll put in a dark fiber ring around their municipality, so that the service providers can come in and offer very cheap internet, high-speed internet, mainly focused at their businesses. For example, here in Okinawa as well, the Okinawa prefecture and many other prefectures in Japan invest into the fiber. They even tap into submarine cables that pass by the island, and there was one that was called the ASE cable, Asia Southeast Express cable, and it bypassed right by the south of the island. And it went to Singapore, Philippines, Hong Kong, and Tokyo. And the prefecture paid and tapped into the fiber. And we used that fiber. We were the first to get to Hong Kong with it. We were the first to get to Tokyo with it. And now we're actually contemplating getting to Singapore with it. So, and all of that requires a business continuity network, right? When I lose a link, I need to be able, not just lose a link. We had one piece of equipment that would brick, would literally no packets could forward in line. And this is quite common, actually, if you read the release notes of a lot of vendors, even on the white boxes. Something could happen, right? And the box could brick, but conveniently the serial port is working, or the out-of-band management port is working, right? So the challenge we're faced here now is we want to use RINA to build this business continuity network, because we want to make money from it now. The reason we have the OOB network is because of all the security vulnerabilities in the existing internet. Whereas RINA is way more secure. So we feel we can do all sorts of business continuity related things on the business continuity network. And one of the things that attracted us the most about the Cardano use case is Oros, Boros, Chronos. And this is the first time we've said this, isn't it? So yeah. It does time, right? So it does time. In all of our data centers, nobody wants us to poke a hole through the roof and put a GPS receiver. Nobody. So we actually find different places throughout our network where we can poke holes through the roof and put GPS receivers. When I worked for a large...
So one thing real quick, for people that aren't educated on Ouroboros Chronos, can you do like a little quick, what is that and why that is interesting to you, and what?
Yeah, I'm not such an expert at how Cardano works, but Ouroboros Chronos, Ouroboros is very dependent on time, right? It's all about time slot. So with Ouroboros Chronos, what they figured out how to do, and in the white paper, I forget the gentleman's name. I don't want to murder it. I'm sure you know it, maybe. The guy that wrote the white paper on Ouroboros Chronos. And it's so attractive because it's a consensus of time.
Yeah. So I've never thought about it that way, but yeah.
Yes, it's beautiful. So it's a beautiful consensus of time. So the problem we have in time today, well, sure, there's a lot of problems. When I start talking about time, I start at the first problem of time. And the first problem of time is that the grandfather clock, the pendulum is supposed to be 1 meter, but it's not. It's shorter than 1 meter, meaning we've compromised time. Congratulations, human beings. And the reason we compromise time is because we use I've talked to Charles about this too when I met him in Hong Kong. I think I talked to him about it as well when I met him at the ADA launch. But no, I didn't talk to him about it at the ADA launch. I talked to him about it in Hong Kong. But we use a version of time that's it's an observation effect version of pi, 3.14159, and a bunch of numbers that never repeat is supposed to be an attribute of a circle, right? So then what Archimedes did was he said, well, I'm going to take 7 Platonic solids that have 22 sides. I'm going to say 22 divided by 7 is pi, which is 3.142. 1428571428571428557, and then we actually have the real version of pi, I would call it, which nobody ever talks about, which is the square root of 2 divided by 0.45, or the square root of 800 divided by 81. Notice there's 2 formulas, and it's smack dab in between observation effect pi and Archimedes pi, and nobody talks about it, but perhaps the grandfather clock would be 1 meter pendulum. What am I talking about? I'm talking about even consensus of pi, which is used to calculate time. Time is nothing but consensus. And right now we have like master clocks, and we're all talking about decentralization. So I think the Ouroboros Chronos is a key piece to decentralization, and a very good use case for a business continuity network to have this. And let's think about it in a RINA use case, right? I can say, let's have the consensus of time based on this version of pi, and then I'll have one based on this version of pi, and I'll have one based on this version of pi, and let's just put all those 3 in the consensus and see who's more correct. It might not be important, you would think, but that's an error at the 3rd decimal place, and in quantum physics. What, you got to go 20 decimal places, and the quantum computing, quantum supremacy, and quantum computing, the number one growing, or I'm not sure if it's growing anymore, but it was growing, was error correction. I mean, there was a lot of folks focused on correcting the errors in quantum physics. Well, do you think if maybe the only
Just wanted to say thank you to our sponsors of the Cardano Aura podcast, Alien Stake Pool. You can see their image right here. Thank you, Alien Stake Pool, for sponsoring the Cardano Aura episode 6. It means a lot. Thank you so much.
It's too perfect. How can you form a circle out of squares? There's infinity, and then you'll go on the internet and they'll say squaring the circle is conspiracy. I don't know. So anyway. Time, right? It's just back to time. Consensus. See, I don't even have consensus with the rest of the world on time. That's an important thing. Instead of grabbing it from the satellites that grab it from the master clocks, and I have 3 master clocks, what is it really? What's the real consensus on time? And I think that finally Cardano is tackling this. And I've thought about it. I mean, I can't tell you how many lunches I've had with friends and engineers talking about time consensus. Getting telemetry from something besides a GPS. We could put radio telescopes can provide telemetry into that, So I think that time, that as we know it, is going to improve. I would say timing, and it needs to for things to scale. I think Cardano's fast, but I think it can be more precise and faster, don't you?
Mm-hmm.
Yeah. So, and there's other use cases. So we're not just after Cardano, right? We're after cryptocurrency. So it's much more secure. Let's say your poor Vert coin, for example, really solid coin that gets 51% attacked, so nobody wants anything to do with it, right? So imagine them having a secure internet. And I'm not sure if you're aware of all the advantages of RINA over the existing internet, but all communications is inter-process communications, is what John Day and his era had originally started to come up with the internet, but they compromised and they started to manage addresses as if though knowing where you are was the most important thing to them, and not who you're talking, not the ability for you to talk, but knowing where you are and how to get to you so that everyone could get to you. So that meant if your blender was in your house on the internet, it had a well-known port. And so everyone knew how to remote control your blender by default because they would assign a well-known port to it.
Yeah.
It made no sense because you don't care about addresses, do you, Peyton? Do you care about your IP address? It's not important. So RINA allows us to manage things by taxonomy. And here's another gem we'll throw out here. So in RINA, we look at it and we can. John Day missed this in his book. I don't know. He's quite a genius. He's very smart, very, very smart man. As a matter of fact, a lot of us in the networking community, one of our most respected folks in the North American Network Operators Group is actually in Japan. He works for a company called IIJ. He's one of their lead scientists, internet scientists, Randy Bush, and he really respects John Day. But these craftsmen we've gone way far on this TCP/IP experiment. And what John missed, I think, was the application of taxonomy to RINA. And so if we look at it like that, think about it like this. Think about a taxa and a taxon. So what is a taxa? Or shall we say, what are taxa? So taxa are the plural form of taxon. There's no such thing as taxons. There's taxa. And a taxon is a singular form. So now let's think about this, right? So a phone is, to you, could be a taxa. But a taxon, right? An individual phone, right? It could be a taxon. But in a way, it's a taxa of phones. And there's also a lot of taxon are within it, the build of materials that go in it, right?
Yeah.
So it's a recursive naming. And with RINA, we could just follow this naming to get to the closest Cardano. So, for example, the staking nodes will not need relays in a native Cardano network because nobody knows your IP address. As a matter of fact, in RINA, in a native Cardano RINA network, point-to-point communications in RINA does not require addresses. They're not even required. Even in IP, a lot of people don't know this, but when I go to IP router, I don't require an IP address on every router. Just one IP address, and then I can go this IP address.
So how does that work? Like, how can you have, how can you have just a network without having individual points on the network? How? To me, that just, I don't know.
Individual points.
Because for example, like you said, relays, right? And just using the Cardano network, you have different relays, and the way you connect to other relays without peer-to-peer is just putting the IP address. So are you essentially just connecting?
Confused a little bit there. So what I'm saying is, if Cardano were on a native RINA network, right? There's no need for a relay. The only reason you have relays is to protect it from the well-known vulnerabilities. So, for example, a relay is listening on TCP port 3001, which is your wallet is connecting to. But when the relay talks to the staking node, is TCP port 3000 now, isn't it? So you're protecting. It's nothing more than a tool to diffuse illegitimate traffic. And in a RINA network, everyone would enroll into the network. Everyone enrolls. So basically, Cardano would say, okay, well, here's the policy. We want this to be the policy of our distributed application, of our DApp, right? So the DApp would have the policy and say, look, if you're not enrolled with us, you're not talking. Just shut up. You're not going to enroll. And that's they call it the DIF, the distributed IPC facility, right? Decentralized. So if I wanted, let's say I had a DIF called Cardano, and I wanted to, I fire up my wallet. And right now they have certain nodes, they have seeds there for you to go to, right? For every wallet, they seed to a list of IP addresses that are there. But if it were native RINA, which is not going to happen anytime soon because they coexist so beautifully. But if it were native RINA, it would just say, "Where's Cardano?" and and that's the taxa, right? Where's my Cardano? And that would be the taxa, and then the taxon would be the closest one to you. So, it would simply be like that. And it would go to the very closest one. And you could set it differently. That's all in your routing algorithm and your policy. But basically, the mechanism's always the same. The mechanism never changes in RINA. And the policy changes. So the API is exactly the same. And that's why we're not afraid to develop with RINA right now, because everyone says, well, this belongs in the academic space. But the academics just drag their feet forever. It's the business space. When we start to sell this is when it'll be adopted, right?
Yeah.
I have friends that own networking companies like Lee Chen, the president of A10 Networks. He's not going to move on this. Juniper, these companies are not going to move until they see the money. And sure, they're all, hey, we're developing it. But if you look at RINA, what's happening is you have like TRIA networks, and every time you talk to it with Charles, he's like, talk to those guys, those experts over there, those RINA experts over there. And we say, what do you mean, this appeal to authority? What happened to good old decentralization? So a lot of these guys have no idea how to build a network. They know how to go to school, but they don't know how to build a network. So they don't know how dense wave division multiplexing works. Let's use that one as an example. So I promised you during this conversation that I would bring RINA into traditional telco. If you actually listen to a lot of John Day's podcasts, he's saying this without saying it. It's very exciting. But RINA is actually it's sort of a pseudo. It reconciles the packet switched with the circuit switched world, or it actually can. So there is no maximum transmission unit for RINA. So if you can imagine, if I had, I don't know, let's say I had 80 light paths, 80 different wavelengths between node A and B. And each wavelength I can do 25 gig. You don't want to do you don't want to do faster than that, because we're talking about the nanometers of the wave and the oscillations of the wave. So really 25 gig is about the best you're going to do nowadays without going to coherent optics. Coherent optics simply means they put a DSP, a digital signal processor, into the optic to make sense of the signal, right? So let's say I have 80 25 gig waves available to me from point A to point Z, which could be, transponded across the ocean. So that's a lot of power, right? With RINA, it could say, well, hey, let's just create this as a flow. Let's just make this one flow, one large flow without frames. Just one stream. So the packet just becomes one large, long flow without the individual frames. So you got to imagine with Ethernet, for example, the largest I've seen a vendor roll out Ethernet frame is, I think, Planet Technologies out of Taiwan. I saw like 10,150 bytes for the frame size. But if you look at like Extreme Networks and things like that, it's like 9,600 bytes of frame size. And then the normal Ethernet on your PC is 1,500 bytes. So every 1,500 bytes, you're spitting out the frame. That's, you're spitting out the frame header. And most of your packets are 64 bytes. Well, of that 64 bytes, 18 of them are frame header. So it's like a tax on every single packet. And RINA has a beautiful solution for that, which means there's really no maximum transmission unit defined. When a process talks to a process, he could say, open her up. Just stream those bits. And everyone says, well, what's the advantage with latency? Well, you do the math. You know, those bits are encoded in bit times, back to time, huh? And we're doing exciting things nationwide in Japan right now with these types of services, traditionally wave services. So we can transpond a wave anywhere. So what does transponding a wave mean? It means like I'll drop 25 gig to your house, Peyton. There in Ohio, and then we'll take and we'll take you at a 1,310 nanometer wavelength to your house, right? Usually to your house, they're going to do passive optical networking, right? So that'll be one wavelength up and one wavelength down. But we're not going to use that example. We'll just say, okay, 1310 nanometers from your house. As soon as it gets to the first station, your first telco station, Cincinnati Telephone, perhaps, I don't know. One of the guys who works for me used to work for Cincinnati Bell, and we just transpond it at that time into we call it the C band. The C band is the one that uses erbium doped fiber amplifiers, EDFAs, and we transpond that wavelength into a channel. And then we take it to the next station. We transpond it to a different channel. So what's a transponder? It takes an optical signal, makes it electrical again, and then sends it out as a new optical signal, regenerated and everything, right? So this technology is very popular in the telco space, and I could see we're whiteboarding many ideas of how to implement RINA very creatively, all the way down to wavelength services. We've done video tests with RINA, frames per second. You know, you can think about it without the framing, or shall we say, you could get rid of the framing altogether, or you can have much larger frames than 9,600 or 1,500 bytes. So
see, that's what I assumed, that you wouldn't get rid of it. You would just increase the amount.
Exactly. And IP works Ethernet. So we're not going to get rid of Ethernet. Here's one thing I want to make sure I say. We're not going to get rid of Ethernet. And this proposal that we're putting forth, we're not saying it, it's tongue in cheek. But there's no way Cardano's going to meet the deadline. We'll meet our deadline. We'll go as far as we can. So right now Cardano goes over IP, right? So if their software is the way it is today, then we'll take it IP, Cardano over IP, over Ethernet, over RINA. If they were to say, okay, well, we can do it right over RINA over Ethernet, then we'll take it that way too, and we'll do the Ethernet shim. But really, there's no equipment out today that doesn't do Ethernet. Ethernet is everywhere. To actually do away with Ethernet and go straight RINA, that goal won't be achieved. It won't be direct Ouroboros over RINA. It'll be over Ethernet over RINA, and we're kind of coming to terms with that right now. But as the development continues, that's the goal, is to get rid of Ethernet.
So is the incentive structure there? Like you mentioned, that these other people just aren't interested in it because there's no money there. Do you think the future, like when you guys build essentially the infrastructure for it and figure it all out, the incentives will be there for these other companies to?
Oh yes. So low latency trading, that's the biggest one right there.
Yeah.
Right there. I'm done.
Mm-hmm.
All my business is point-to-point circuits. You know, I can't tell you the customers I've got on my network, but if I start telling you who they are, you're like, wow, those are like famous companies. They all want point-to-point circuits. They want those wavelength services. They want those Ethernet point-to-point services. And there's many ways that we offer those today: VXLAN, Q&Q. There's all sorts of overlays, MPLS, VPLS. There's all sorts of overlay schemes and fabrics. Ethernet over Ethernet, shortest path bridging, MAC in MAC. That's what that one's called, right? We use that. We use all of those technologies. We have to today. And it really consolidates all of those VPN technologies into one with RINA. And I think that's the big sell, is the point-to-point circuits, especially the low latency ones, because the traders want what? And arbitrage. Think about Ouroboros Chronos. maintaining time. If I can somehow extract time from Cardano into my network so that my network doesn't just rely on the GPSs and it can rely on a more of a consensus-based time, the huge impact that would have for networks, low latency networks. I can actually determine what the heck is going on with the packets, right? So right now we use a lot of different streaming telemetry techniques, but nothing is really so accurate from point to point because time is always off. Even people will say the GPS, oh, GPS is always on. You'll see, oh, it looks like it turned perfectly, but no, it's off. there's always some issue there, especially like a network device that has to deal with all these security issues, and its CPU is just a little high. So by the time you get the time, it's always just a little off, especially at the logging server. Yeah.
Yeah. So what advantages do you have using over Ethernet over RINA versus obviously the best case scenario where everything's just RINA? What advantages do you have using that hybrid model?
Oh, so this is just so a lot of people say, what are the advantages? What are the advantages? Our advantage, first of all, is just traditional hardcore telco. Everyone else is sitting out there using the cloud. I'm gonna be in the core of the internet. I mean, look, those I bring you to the cloud, right? Mm-hmm. I'll be before that. I'll be before you. I'll be in the core of the internet on waves, talking to the core of the internet, right at the internet core routers with our use case. All it is a use case. So that's a pretty good advantage right there. Now, RINA itself, Ouroboros over RINA itself, I just think it'll just really enjoy that environment if I have to use it over IP. Once they strip away IP, it'll blow away everything else. I mean, think about it. Everyone else is sitting on gig servers on Amazon or Vultr or Google or wherever they're at, Azure, or at home. And they're using IP headers with every packet. Well, let's just take that away. That's time. That's all time. As far as advantage, stability is the only advantage I would see with Cardano. I don't think the speed that I'm talking about, being in the core of the internet, but being there is going to give this pool a really good use case that I would hope the goal would be for it to be just as good, if not better, than any of its peers. That is victory, right? Because it's all about scalability. It's not about, who can I beat? Mm-hmm. It's about how can we all build something that lasts without having all these craftsmen in between that are not necessary. I mean, if you see what my guys do and they spend their days doing for things that would be so easy in RINA, it's pathetic. In RINA, we just enroll. Nowadays, we have a whole procedure we have to go through just to get them enrolled.
So do you think that these decentralized networks that we're building in terms of transactions per second, do you think that we're going to reach limits with TCP?
Oh, yeah. Oh, definitely. It's all centralized. So I call it, in Japan, the term is Sankin Kotai, and that's where the emperor, the shogun, not the emperor, but the shogun made all the generals report to Tokyo so that he could train them and then send them back to their local prefectures. Of course, keep their family there as ransom. So that's what's happening in today's internet. If you're, for example, in Japan, if you're in Okinawa and you want to talk to your next door neighbor and he's on SoftBank, you have to go through Tokyo. It's really centralized. The existing internet today is centralized. TCP, as it was the only congestion control mechanism that they put out there, and when they did it, they knew it was just basically putting the problem off. And now with the denial of service attacks, the Internet of Things. So imagine the Internet of Things getting a vulnerability where all of a sudden now you're getting blasted by common household appliances. So we've got to take action. There's no reason. Imagine if you just quit telling everyone your address and just said, "Look, man, it's like when we interacted for this podcast. You said, "Here's my name. Boom, connect to me on Discord," right?
Mm-hmm.
So it had nothing to do with any address there. I don't need to know your address to have this conversation. It's not important. But that's all the internet is about today. All routing is to addresses. And then when I'm done creating the routing table, I still don't know who anybody is. I need to ask somebody else, hey, how do I get to this name? So we need to build directories, and those directories need to be taxonomic and scalable. And we need to connect locally. And people say, well, but we'll lose control. Actually, not really. If I were, I don't get me wrong when I say this, but if I were a dictator in some country, I would love RINA, because it would be like, okay, you get this diff and this is the policy, and you get this diff and this is the policy. And as somebody in a freer world, I love it too, because if somebody's behind a dictator, if he won't let them talk about this or that or this or that, do I just not want to talk to him? No. If they want to talk about dance, let's talk about dance, right? Let's dance. Let us communicate. And in my career, I've had people say, that we're communicators, and say, we're not important. We're not like doctors. Yeah. Well, doctors like to talk to each other. So. That's the exciting part. And that's the exciting part about RINA, because it allows all these different policies to exist. It's a real internet where any group can have their policy.
Yeah.
And it's respected.
So as far as your proposal, how much are you asking for, and what will get done with that?
Oh, that's a good one. So personally, we're going to fund it regardless, right? So basically we have $20,000 US about that I've already ordered, which some Dell PowerEdge servers, 640s, and some optics, cables, and then our company's going to donate the rack space and everything like that.
Yeah.
So really, the real honest to goodness reason to get any money from the fund is to stick into the use case, the pool, right? So that we can pledge the money, right, and have the pool. Another thing we're seriously considering is bounties. So when we get the money, so since our company would hopefully pick up the cost of all the equipment and stuff to do the testing, the use case proof of concept on RINA.
Mm-hmm.
We would hope that we could pay bounties and say, even back to IOG themselves, and say, okay, look, we've got, IP over RINA working. Do you think maybe we can go on some testnet code on an ITN and spin up a testnet node and start to get there over Ethernet? And then I have great relationships with manufacturers. And do you think maybe we could build some sort of transponders, some transceivers that have RINA on it, and maybe we don't have to frame anything in Ethernet. Maybe we can just use DTP framing, data transfer protocol, is what RINA uses. That's the ultimate goal, and pay bounties for that. A lot of companies for development nowadays, they're not going to develop anything until they see the money. So that would be another goal of ours. So we're asking for the cost of what the hardware would cost had we not done it. But the reality of it is we hope to put that money into the actual pool so we can pledge it right back, and then use all the proceeds to keep talking to manufacturers and developers to get us closer and closer to the ultimate goal, which is Ouroboros straight over RINA without Ethernet or any other framing protocol in between.
Yeah, that's awesome. Where would you recommend people to go to learn more about RINA?
RINA, to learn more about RINA.
Yeah,
that's the Posen Society.
Because to say this is their introduction, this is their first time ever hearing it, and they're really interested in this stuff, and they love hearing about the bleeding edge. Where would they go?
Yeah, there's only one place. And I'm texting it right there to you.
Cool. Yep, I'll include that in the description down below.
Yep, there's only one place, and then of course we're RINA, we're RINA user group ourselves for our website, and we have a YouTube channel, and we're going to keep reaching out. We're excited about networking. Most of the people in our group have no affiliation with Cardano. No, don't even own one ADA.
Mm-hmm.
This is way more exciting than just Cardano. Cardano offers like a leg to the stool. Like I was talking about Ouroboros promos.
Yeah.
But our heads are down, and we're going to develop RINA regardless. And Charles, we know Charles is in love with it from common sense roots. Yep.
You cut out there for a second. You said you know Charles is what?
He's really pro RINA. It's one of the things he wants. At the ADA launch in Tokyo, it was on his slide. I want RINA. So we hope to appeal to the pioneer spirit here. You can't just keep things in academia. What's happening is like TRIA networks and stuff. They're trying to take it into the commercial side, and they're keeping things secret. Whereas our plan, we have a GitHub repository, and we've already developed a lot of code privately. But once we test it and start to deploy it, we will publish it and make it completely open source.
Okay. Yeah, I think a lot of people will like that. Yeah, and I'm right there with you. I just I've always had the pioneer spirit, so this is really my first introduction to it, and yeah, I'm definitely going to dive in and learn more about it. But we are running out of time. Is there anything else you'd like to say before we log out of here?
No, I could talk all day about how excited we are about RINA, and
there's always more podcasts. Especially with what you guys are doing, I would love to hear you come on and tell me how it goes, and specifically letting the stake pool on RINA, and especially if there's some sort of RINA test net that's going on, and you do have that bounty for that. That'd be awesome. I'd love to hear more information about that.
Yes, we'll post that on our website.
Cool.
RINAuser.group.
Yeah, well, all those links that you sent me, I will include in the description down below. And I just wanted to say thank you for taking the time and coming on this podcast. I really appreciate it. And also, if the proposal doesn't get through, I would say try again, because this is only fund 2. And I think there's only like 2.5 million ADA in the first fund. There's not much money in that first fund, so I think a lot of them won't get through.
Yeah, we don't think we can fail. We're going to do RINA, and a lot of people are going to want it, right? So,
Mm-hmm.
and I think that the Cardano community is going to see some success in
and
we're going to do a poll regardless. They'll see some success.
Yeah, I see what you mean, and that's why I could see how the community would believe in this, and that's why I was saying maybe you should go for an alternate fund if this one doesn't get through, But
okay, yeah, thanks, Peyton. I appreciate it.
Yep, no problem. Well, thank you guys for tuning in this video. If you enjoyed it, make sure you leave a like and a comment down below. I'll also be in the Discord server after this is uploaded, so feel free to come by. But I hope you guys all have a wonderful rest of your weekend. Goodbye. I hope you guys enjoyed the Cardano Aura episode 6. If you made it to the end of this video, please type number 6. Let's keep it going in the comments down below, and I'd really appreciate it. Also, one more thank you to our sponsor of this video, Alien Stake Pool. Thank you so much. The link will be down below.